So 2 classes ago, we did solving by graphing. You just graph them. The answer is where the two graphs do what? Intersect. Perfect. You just look at it, right? Use Desmos and just look at it. What we just practiced reviewing is called what? Thank you. Substitution. You're replacing something with something else. What we're going to do today is another method of solving is called elimination. It's where you eliminate one of the variables. Everything is exactly what it sounds like. So you eliminate one variable by adding the equations together. So you're going to look for or create what are called additive inverses. And that's, if you can't read my handwriting, because I know my handwriting is not great, it says additive inverses right here on the paper. And I'm going to go through a couple examples of them and explain to you what that means. But it basically just means they cancel out. That's it. You're just trying to get something to cancel out or eliminate. That's the goal. So look at this one. It's negative 4y. The way you would cancel that is with a positive 4y. Not rocket science. You're all with me here? Negative 4y, positive 4y eliminates. They're gone. It's the idea. So how about 7x? What would the negative 7x? Good. You're just looking for a way to cancel it out. So how about 5x? Negative 5x. Yeah, now x and y won't cancel. It has to be the same variable. And then how about this last one? You've got a negative 2y. What would cancel that? Positive 2y. All right, so negative and positive of the same number are going to cancel out. All right. So you solve for the remaining variable. It ends up being really easy peasy. The problem kind of like disintegrates. All right. Substitute that variable into one of the original equations. You've been doing that. In the little activity you just did, when you got x equals 7 or whatever it was, you took 7 and plugged it back in. Remember that? Or if you got y equals 5, you took 5 and plugged it back in to get the other one. And then lastly, and you've been doing this, you want to write your answer as an ordered pair, which means something, comma, something. It should be an x, comma, y. So I want you to be a good noticer. This is great. You're all focusing and listening to me. I love it. Let's keep it up. Look at example 1. Which variable, x or y, is already going to eliminate? Do you see that? How the y's are already going to eliminate? So all you're going to do is add them together and the y's are gone. Isn't that cool? Now add them up. 4x plus 3x, 7x. Good. That's all you're doing. Equals. Now you're not going to write the y's because they're gone. That's like kind of the whole point. And perfect. And then just keep going. What would you do to solve that? Yeah, divide by 7. X is 3. Beautiful. I honestly like this method better. I think this is easier than substitution. That's my personal opinion. Now, you want your answer to be 3, comma something. 3 is the x, so I put it first. Now, with substitution, I just kind of coached you through doing this in your head. It's a little tougher for elimination. I'm going to actually write it out. We're going to take 3 and plug it back in for x. It doesn't matter which equation you pick, but I just always pick the first one because it's the first one, right? So we're going to plug 3 back in for x. 4 times 3. 12. Good. So we're going to have 12 minus 2y equals 10. We just took 3, plugged it back in for x. 4 times 3 is 12. And then I just wrote the rest of the line. And bless you. And then you just finish solving that. Bless you. So what next? You guys know how to do this part. Yeah, minus 12. Good job. Okay, and now you're ahead of me. You divide by negative 2. What is negative 2 divided by negative 2? It is 1. You could use a calculator. I like the computers put away while I'm teaching because it's a respect thing, but you would type it in the calculator is what you would do. All right, let's try another one. Looking at example 2, which variable x or y is going to eliminate? So just add them together. And the x's eliminate. That's like the whole point. So just add the other columns. Negative 5y plus 2y. What's that? Negative 3y. I like this because the answer kind of just falls into your lap, right? Negative 35 plus 32 would be, it'll be negative 3. The 3 was the right number. It'll be, why is it negative instead of positive? Yeah, and the bigger one is the negative one. All right, so then we divide by negative 3 and we get positive 1. The negatives cancel out. Good job. These are good with your negatives there. So when you write it as an ordered pair, where does the 1 go? Yeah, on the right, the y, the second part, because it's y. And you're going to take 1, plug it back in for y. I usually use the first equation for no other reason than it's the first one. You just have to pick one. So you're going to have 5x minus, now we want to plug in 1 for y. So 5 times 1 is just 5. And then equals negative 35. We plugged 1 back in for y, so it kind of looked like it went away because... No, if this was a negative 1, then the negatives would cancel and we'd have a plus 5. Good question. All right, and then what? Then you just keep going. Plus 5. So 5x equals negative 30. Divide by 5. It will be negative. Does anyone know 30 divided by 5? Negative 6. Now, I need to see you showing your work, but let me show you for a second. We'll do one more and then I'll give you your break because you're all being good and paying attention to me. Here's my Desmos calculator. There, that's what I want. Let me share my screen so this ends up on the recording and just show you really quick. A way you can check your work is, now you can't just do this to get the answer. A lot of you learned that the hard way. You need to actually work the problems out. But let's look at example 2, the one that we just did. And you guys watch me type this and make sure I don't make a mistake because I made a mistake last time and you guys had to call me out on it. Negative 35. Did I type that one right? Okay, and then what's the other one? Minus 5x plus 2y equals 32. Click on the intersection. What do we get? Negative 6, 1. That's our answer. You can do that to check your work, not to do the problem. You have to actually show work. Okay, I want to see all of this. But you can do that to check your work. All right, we'll do one more, and then I'll give you a break. There's not a whole lot of notes today. All right, do you see anything that cancels out or is close? Now, the x's are close to canceling out, but what do we need to do? A negative to get it to cancel out. So here's what you do, and this is going to be a little bit of writing, but you're going to be okay. Copy the first equation. Literally just write it. And my pep talk for that is I could bring a 3rd grader in and be copy that over and they could do it because I'm not asking you to actually do anything, just rewrite it. Now, the second one, we're going to multiply everything by a negative 1. What will that do? What is the purpose of it? It'll all be opposite. You're flip-flopping all the signs. So it will be negative 2x and then plus 7y, good, equals, positive 15. And then why did we do that? Why on earth would we have done that? Now what's going to happen? You can eliminate the x's. You can cancel out the x's. So if it doesn't work out, you have to force it to work out. All right, add them together. What do we get? 5y plus 7y, 12y equals 12. Good. And so, good, y equals 1. I love that. The answer just sort of falls into your lap. All right, now your answer has to be something, comma, something. What are we going to do next? Put the 1 to the right. That's the y value. And then you're going to take 1, plug it back in for y. I just used the first equation because it's the first equation, all right? So that's going to give you 2x plus what? Good. Why just 5? Because it's 1. 1 times 5 is just 5. Equals negative 3. And then just keep going. So now what? Minus 5. What is that? Negative 8. Kind of being your calculator for you here. Divide by 2. Negative 4. And not to do the problem, but to check your work, what could you do? Plug it in Desmos. Click on the intersection. Okay. Now, sometimes you have to really manipulate them to get something to cancel out. And remember, who's in charge? You are. You are in charge of the problem, right? So when you look at this one, which variable, x or y, looks easier to mess with? The y's look easier. How come? This one's already sort of by itself, all right? You want to deal with smaller numbers rather than bigger numbers. So if this one is negative 2, we want this one to be positive 2, okay? So we're going to multiply this whole equation by 2. The most common question I get asked is, Miss Cole, where did the 2 come from? It came from our brain. We came up with it. It didn't, like, we came up with it. If this is a -2, we want that to be a +2. So you have to come up with that. All right. Distributing a 2 through there, what's that going to give you? 4x plus 2y equals 10. And then you will literally just copy over the other equation. Don't change anything. Just literally copy it exactly as it looks. You have to write a little bit. You're going to be okay, though. Promise. Now, the purpose of that is the y's eliminate, and then the answer is going to sort of fall into your lap. When you add these columns up, what do you get? Good. Well, 7x equals 14. Good. And then x equals 2. I love that. I like this method a whole lot better than substitution, is my personal preference. Now, when you write your ordered pair, where does the 2 go? No, good. You guys are on top of that. Nice job. And then you're going to take 2 and plug it back into the original problem for x. And I just always pick the first one because it's the first one, right? So follow me here. I'm just going to point to it. If you plug 2 in for x, I know the door opened, but look up here, right? If you plug in 2 for x, 2 times 2 is 4 plus y equals 5. And then you would minus what? You would minus 4. Well, I replaced the x. Hold on, let me get everybody there. X is 2. So I replaced the x with 2. 2 times 2 is 4. Is everybody with me? Yeah. Okay. 4 plus y equals 5. So what is y going to equal? You subtract over the 4. 1. That bothers you guys way more than me. If you're awake and talking to me and interacting with the lesson, I'm thrilled. I don't care. 5 minus 4 is 1, though. Go ahead. Yeah, I would not use the one that you manipulated. I would use the original one because it's easier. I always want you to do the easiest way. Now, looking at this one, it kind of doesn't matter if we change x or y because they're all sort of a mess. So do you want to get rid of x or do you want to get rid of y? What's your preference? We'll get rid of y. Now I want you to look at this. There's a 3. You're going to have to really use your brains on this one. This is a 3 and this is a 4. We need to come up, get your head up. We need to come up with a number that we could turn them both into so that we can slash them out. 12. Good. What will we multiply this equation by to 4? Where did the 4 come from? Our brain. We came up with it. That's not going to be given to you. You have to come up with it. Now, if you distribute a 4, that's going to give you 12x plus 12y. 4 times 9 is 36. I'm sort of being your calculator there. You could use Desmos. Now, I don't want the other one to be 12. I want it to be -12 so that they'll cancel. So good. Where did the -3 come from? Albert, you have to come up with it. So that's going to give you, and some of you are flying through it already, -15x minus 12y equals -30. Good job. That went way better than I was expecting it to. Very nice job, Ben. So the y's eliminate. That's why it's called elimination. That's sort of the whole point. Add your columns. 12x minus 15x. Good. -3x equals 36 minus 30 is 6. And then the answer just sort of falls into your lap. The whole thing kind of goes away. So divide by -3. -2. So where does the -2 go in your ordered pair? The first one. Again, you guys are on top of that. Very nice job. And we're going to plug -2 in for x in the first equation. I'm going to cover this up because I wouldn't use that part. All right. If you plug in -2 for x, 3 times -2 is -6 plus 3y equals 9. You're kind of just copying the rest of the line. You're taking -2, plug it back in for x. And then you just solve that. Plus 6. 3y equals 15. And y is 5. And what could you do to check it? Desmos, click the intersection. You can't do that to get the answer. I need to see your work, but you can do that to check your work. All right. Looking at this one, does anything eliminate right away? No. Do you want to try and get rid of X or get rid of Y? It really does not make a difference to me. Let's get rid of X in this one. Hold on, let me stop this pass.
6.
Okay. You could make them both be 6 or 6 and negative 6. So what are we going to multiply the first one by? 3. Distribute a 3 through there. Where'd the 3 come from? Us, our minds. We came up with it. Didn't fall out of the sky, all right? So that's 6x plus 12y equals 3. Just multiplying by 3. Now, if this is 6x, we want this one to be negative 6x. So you would multiply by a negative 2. Again, you have to come up with that. That's the one thing that's kind of hard. You have to come up with that, but you just want them to cancel out. So that'll be negative 6x minus 12y equals negative 2 times 5, negative 10. Now you should already be going, hey, wait, hold on a second. Something seems a little weird here. Yeah, do you see how they both go away? It would be 0, because it's all gone, equals, yeah, negative 7. Does 0 equal negative 7, or does that make any sense? No. And if you were to graph them, what would they look like? Perfect. Parallel. Oh my gosh, I'm so proud of you guys. This is going so well. All right. This one, do you want to get rid of X or do you want to get rid of Y? It won't make a difference. That's why I'm Y. Okay. If this one's a negative 6, we want this one to be a positive 6. So it has to come from your brain. What will we multiply by to turn that into a positive 6? Negative 2. Good job. I'm going to distribute a negative 2 through there. So that will give you negative 4x. And then what? Just keep distributing. Good. Plus 6y. Equals negative 2 times 6. Negative 12. Sorry, I ran into the hole punch. And then the other one, you're going to just copy over. We don't need to change that one. So just copy it. And you should already be going, hey, wait, this is a little weird. It's different from this one, though, so don't start screaming no solution at me. Literally everything cancels. So you get 0 equals 0, which is true. And so it is infinite, bless you, solutions. Now, the word problems, I am fine with you just using Desmos for, because you have to set it up yourself. So we'll set this up, and then I'll just plug it into Desmos, okay? And make sure I've got Desmos ready to go. But you have to set it up. I feel like you guys are getting real good at this, though. Let's read. The school Stefan goes to is selling tickets to a choral performance. First day of ticket sales. We sold, are you with me here? 3 senior citizens. So I'm going to let senior citizen be X. And then what's the other type of ticket we have? Child. So I'm going to have child be Y. Okay, that's the first thing that you do. So let's set up our first equation. It would be 3 X, good. You don't overthink it. You're just kind of putting it all together. Plus 1y, good, equals how much money? 30, good. You just have to read. Put it all together. All right. And then they took in $52 on the second day. 3 senior citizen, 2 child. So put it together. How's that going to go? 3x plus 2y equals 52. Now again, and on your delta math as well, I'm fine with you just typing this in the calculator because you had to set it up yourself. But can you guys watch me, make sure I don't mistype something? Because if I do that, it's going to be wrong. Now, what is this? 3x plus 2y equals 52. All right, it looks like it's gone, but that's just because the numbers were kind of big. Here's our intersection, 8, 14. Now you need to know which one's which. So it's 8. 8 was x. Perfect. Nice job. 8 senior tickets. And then, oh gosh, I forgot it already. Was it 14? I got it from the calculator. Hold on, let me look back. Yeah, 8, 14. So 14 child.